Alright, geometry, we are still looking at Unit 7, which is right triangle trigonometry, but now we're going to be doing solving triangles, or finding pieces with multiple triangles that have shared sides. So, well, let's just jump right in. Here we go. So notice here that this is kind of one triangle, but it's really like split into two triangles. We're going to do each one individually, because this blue line down here, down the middle, that if we figure it out for one triangle over here on the left side, it helps us with the second triangle over here on the right side. So first, let's find the length of this blue line. Well, I see the 36, the 20 degrees, and let's call this, I don't know, H. No, not H. Let's call it A. Or X. Yeah, how about that? No, we got an X right there. Let's call it Y. Okay, so this is Y. Now that we figured out a letter that we could use. So we have these three pieces. Notice we have an angle. This blue line is adjacent to that angle, while the other line is the hypotenuse. So adjacent and hypotenuse should use cosine. Okay, so we're going to say cosine of 20 degrees is going to be the adjacent over the hypotenuse, which in this case is y over 36. Oh, that was pretty easy. Now all I got to do is multiply both sides by 36, and then I'll get 36 times cosine of 20 degrees equals y. Well, degrees. We go to 20 degrees, cosine is the middle column, so that's going to be 0.94. And then, so I'm going to do, what was it, 26, 36? I can't remember. Let's go back and check. It was 36. 36 times, oh no, I forgot again. What was the calculation? 0.94. 0.94. That gives us 33.84. So back here on this means that that piece right there is 33.8. That's a 33.84. So it's 33.84 for the triangle that I was just working with, but it's also 33.84 for this triangle here. So 33.84. And how does that help me? Well, now I have a side, a hypotenuse, and this angle. Let's do those in different colors there. We'll do the second half of it in red. 33.84. So let's do this part now in red. So this is 33.84, and then we have this angle and this x. Now we can make an equation using the red pieces. Well, the 33.84 this time is opposite, so we have the opposite, and the x is the hypotenuse, so that'd be sine. So we're going to have sine of 55 degrees is the opposite, which is 33.84 over x. Now we got to do a bunch of, moving stuff around. Algebra, you could say. Sine 55, so the x is simplified. Sine 55 simplifies. X equals 33.84 divided by sine 55. Well, let's see what sine of 55 is. Check our little chart here. We go to 55. It's in the middle group. And right there, 0.57. So that's going to be equal to 33.84 divided by 0.57. And what does that come out to be? Okay, well, I don't know. Let's check. So we're going to take our number, 33.84, which we got. We're going to divide that by 0.57. And that gives us 59.37. So this is 59.37. That's x. Check. Done. That was a piece of cake. Almost too easy. All right, now we're going to do the same kind of thing for the next one. We'll start out by doing half of it in blue and then half of it in red. So we'll call this middle vertical line here, an altitude you could say, is y. And with the 28, the y, and the 56, I know that we have the opposite over the hypotenuse, because I got the y is the opposite and the 28 here is the hypotenuse for the blue group. That means we're going to do sine. So sine 56 equals opposite y over 28. So we're going to multiply by 28 times 28. Let's see what sine of 56 is. Okay, so 56 is 0.56. Whoops, no, 0.83 when we're doing sine. 0.83 times 28 is going to be 23.24. 23.24. So y equals 23.24. Now that's cool because now we can reuse it, 23.24, on the red group here with the x and the 49 degrees. Again, we have an opposite, the 23.24, an x for the hypotenuse, and this time 49 for the degrees. So that tells me that sine, because we have the same relationship, the opposite and the hypotenuse, which goes with sine. So sine 49 degrees equals the opposite, in this case is 23.24 over x. Right, so we got the whole algebra going on and dividing, multiplying. This gets kind of repetitive because we've been doing it so much at this point. But x equals 23.24 divided by sine 49, which happens to be, let's see if we can find our table, sine 49.75, which altogether is going to be 23.24 divided by 0.75 is 30.986, or 30.99. Let's just say 30.99. Cool. Cool, cool, cool. Oh, it says round your answer to the nearest tenth. Yeah, whatever. No big deal. We went to hundreds. Still good. Let's see what we got next. Okay, now again we got half and half. I'm gonna start doing probably about every other one at this point, just so you guys get enough practice. But then you'll probably get the point after that. So we got 50, 70 degrees, and this vertical line here, the altitude. I see that the blue line is adjacent to the 70 degrees, and the 50 is the hypotenuse. So if we have an adjacent, a hypotenuse, that's going to be cosine. So cosine 70 degrees equals the adjacent, which we don't know, we'll call it y, over 50. Well, we're going to multiply by 50, multiply by 50. And what's cosine of 70? Well, let's look it up. Cosine of 70 degrees is 0.34, according to our little table. So we'll have 0.34, I think it was, 0.34 times 50. 17. Just let me double check. 0.34, yep, that's what it was. And altogether this became a 17 equals y. Because we got 17 for y. And now we have this 30 degrees. Let's start doing this as a red group. So we got x, 30 degrees, and this is 17. That gives me another adjacent, and this time the opposite. So we got adjacent and opposite. So what's opposite over adjacent? That's tangent. So we're going to have tangent 30 degrees equals the opposite side, which in this case is 17, over the adjacent side, which is x. Okay, how are we going to do this now? Alright, let's see, that would be multiply both sides by x, divide both sides by tangent 30, tangent, simplify, x's simplify, so x equals 17 divided by tangent of 30, in this case, is 0.58. Which if we calculate it now, that's going to be 17 divided by 0.58. And that gives me 29.3. Oops, 29.3. There we go. Cool. Awesome. Super, super awesome. All right, let's keep going. Let's keep going. All right, let's just do the odds now for sure. We got 50 degrees. Let's go blue group, then red group. So not 50 degrees, 61 degrees, 50, and this blue line, which we'll call y again. Okay, so let's see, that y is opposite the 61 degrees, and then 50 is the hypotenuse. So we have opposite, hypotenuse, that means we're going to use sine. So sine of 61 degrees is equal to the opposite y over the hypotenuse 50. So 50 times sine 61, little table, what 61 is, when I take the sine of it, that's 0.87. So it's going to be 0.87 times, what was it, 50? Yeah, 50 equals 43.5. So this is y equals 43.5, which is the same value when it's over in this triangle, 43.5. Now we have the opposite, the adjacent, and sine 70 degrees. Okay, well, or not sine, tangent, because we got opposite and adjacent, which means we use tangent. So tangent of 70 degrees equals the opposite, which is x, over the adjacent, which is 43.5. Cool, cool, cool. This one's actually a little bit easier to solve than some of the other red groups we've done. We just multiply by 43.5 on each side. And that'll give us x. So 43.5 times tangent of 70. Well, tangent of 70 is 2.75. So I'm going to do 2.75 times, what was it, 43.5. Oh, it's the answer that we just got. Second answer and done. 119.625, or just 119.6 would be good enough. So x equals 119.6. Sweet. Let's do one more, just for fun. Because do they really get any harder? Actually, we'll do a couple more, because I have a feeling that 87 has kind of a shortcut built into it. Let's see. So we got 24 degrees, the 15, and this y here. The y is opposite the 24 degrees. The 15 is the hypotenuse compared to the 24 degrees. So I got opposite, hypotenuse, that would be sine. SOHCAHTOA. Remember, I'm getting all this from the SOHCAHTOA relationship. Okay, so sine 24 degrees is opposite, which is y, over hypotenuse, which is 15. So I'm going to multiply both sides by 15. And sine 24, 24 degrees is going to be 0.41. Okay, so 0.41 times 15. 0.41 times 15 will give us our calculation. 6.15. Because right here we had 0.41 times 15. And what was it again? I just lost it. 6.15 equals y. Now if we transfer that over to the other angle, the other triangle, 6.15, here's something that's kind of cool. This is a 45-45 triangle, which means both of these pieces are 6.15. At this point, you could use Pythagorean theorem or trigonometry to do it. I'm still going to use, trigonometry, but I just wanted you guys to see that we could use either one, because it's kind of interesting there. With 45 degrees, you have some symmetry going on, where it's an isosceles triangle as well as a right triangle. So let's see. How about we use the same one like we normally would have, and this x and that angle. That means we have the opposite, the hypotenuse, and the angle again. So that, again, we'll do sine. Sine 45 degrees equals opposite, which is 6.15, over x. Now we got all this algebra. We're going to multiply both sides by x, divide both sides by sine 45. X equals 6.15 divided by sine 45. Okay, sine 45, if we look at the little table, 45 and sine, which is the same as cosine because it's symmetrical, is 0.71. Okay, so 0.7. So we're going to take 6.15 divided by 0.71. That gives us 8.66. X equals 8.66. Well, I'm actually going to cut it short, probably just leave it there. Yeah, because it's just repetitive. It's the same kind of idea. Each one's got its own relationship, but big clue, always look for this middle line. Why? Because it's the same for the left triangle and the right triangle. It's kind of like a bridge. It allows you to do the left side and then the right side there. Cool, 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 cool. Alright, this is the end of part 3 of 4. We will see you in part 4 of 4.